Dear students, in the previous video, I started the exercise 13.1 in the chapter 13, limits and derivatives. And I have solved some problems in the exercise 13.1. Now in this video also, I am going to continue the exercise 13.1. In that exercise 10th problem, evaluate limit z tends to 1, z power 1 by 3 minus 1 by z power 1 by 6 minus 1. To solve this problem, substitute z power 1 by 6 equal to y. That is, z power 1 by 6 the whole square equal to y square, squaring both sides. Z power 1 by 6 the whole square is z power 2 by 6, that is z power 1 by 3. Squaring 1 by 6 is 2 by 6, that is z power 1 by 3 equal to y square. So this z power 1 by 3 can be replaced by y square as limit z tends to 1. Z tends to 1, y tends to 1. As limit z tends to 1, y also tends to the limit value 1. Y tends to 1. Therefore, limit z tends to 1 is replaced by limit y tends to 1, y square minus 1 by y minus 1. This one, numerator 1 I can rewrite by 1 square. Limit y tends to 1, y square minus 1 square by y minus 1. It is of the form limit x tends to a, x power n minus a power n by x minus a. The result is n into a power n minus 1. 2 into a is 1. 2 into 1 power 2 minus 1. N is 2. Therefore 2 into 2 power 1 power 2 minus 1 is 1 power 1 is 1. 2 into 1 is 2. That is the answer for problem 10. That is the solution for the problem number 10. Next, 11th problem, evaluate limit x tends to 1, ax square plus bx plus c by cx square plus bx plus a. In this case, the sum a plus b plus c is not equal to 0. Therefore, substituting the limit as x tends to 1, numerator is a into 1 square plus b into 1 in the place of x I have to substitute 1 plus c by c into x is 1 square minus plus b into x is 1 plus a. So this is a plus b plus c in the numerator. Similarly, the denominator is also c plus b plus a. That is nothing but a plus b plus c. Numerator is a plus b plus c. Therefore, the result is 1. Dividing by a plus b plus c by a plus b plus c, answer is 1. That's all about the problem 11. Next, we will see problem 12. Problem 12 is evaluate limit z tends to minus 2 1 by x plus 1 by 2 by x plus 2. This is the problem. Limit x tends to 2 1 by x plus 1 by 2 by x plus 2. So this problem I can rewrite by limit x tends to minus 2. Numerator I can take LCM as 2x. Therefore 2 into 1, 2 plus x into 1 is x. By taking LCM as 2x, 2x divided by x is 2, 2x divided by 2 is x by x plus 2. Again, this is a limit x tends to minus 2, 2 plus x by x plus 2. The denominator, numerator to denominator becomes the denominator 2x. Okay. Now x plus 2 in the numerator and x plus 2 in the denominator get cancelled. Therefore I get limit x tends to minus 2 1 by 2x, substituting x equal to minus 2 here, you will get 2 into minus 2, that is equal to minus 2 into 2, 4 minus 1 by 4 is the answer. That's all for problem 12. Next, problem number 13. Before solving problem number 13, we will consider one result for a limit of a trigonometric function, limit x tends to 0, sin x by x equal to 1. This is the result. You have to remember, limit x tends to 0, sin x by x is equal to 1. This is one result. Already we have derived limit x tends to x power n minus a power n x minus a, that is n into a power n minus 1. Similarly, the limit of a trigonometric function, limit x tends to 0, sin x by x is 1. So using this result, I can solve one problem. Example, limit x tends to 0, sin ax by ax. Limit x tends to 0 implies ax is also tends to 0. So similarly, limit x tends to 0 implies it is also we can solve by limit ax tends to 0. Both are same. Limit x tends to 0 or the limit ax tends to 0. Therefore, this is sin ax by ax. It is of the form. Answer is 1. For this problem, the limiting value of the function is 1. That's all about the problem example. Next, using this result, I am going to solve problem number 13. Evaluate 13th problem. Limit x tends to 0, sin ax by bx. So, to solve this problem, limit x tends to 0, I divide the numerator sin ax by ax. To compensate that, I multiply the numerator by ax. Multiply denominator and numerator by ax. I get sin ax by ax into ax by the term bx is there. Now I split this limit into two limits. Limit x tends to 0, sin ax by ax into the term ax by bx. In this product, here x cancel, limit x tends to 0, sin ax by ax, limit ax tends to 0, we can easily write this x tends to 0 means ax tends to 0. Therefore, this limiting value is 1 and this is a by b. 1 into a by b is a by b. That is the solution for problem 13. Next problem. Problem 14, limit x tends to 0, limit x tends to 0, sin ax by sin bx. Here, a comma b not equal to 0. In this problem, limit x tends to 0, sin ax by ax, you multiply and you divide the numerator by ax. Similarly, in the denominator, you multiply the denominator by bx and divide bx. Here also, I can split this limit into two limits. Limit x tends to 0, numerator sin ax by ax divided by denominator problem limit x tends to 0, sin bx by bx. I can split the division entire limit into numerator limit separately and divide the denominator function, apply the limit separately, and I will get ax by ax, the remaining ax by x, you separately take it, and you can cancel numerator x and denominator x, and the limiting value of the numerator function limit x tends to 0 sin x by x is 1, denominator is 1. Already you have a by b, therefore solution for this problem is also a by b. 14th problem is also answers a by b for the problem 14. Next, like that you will solve using that trigonometric result, we will solve the sum. Next problem 15. The results you have to remember, then only you can solve the problems easily. Fifteenth problem. Limit x tends to pi sin pi minus x by pi into pi minus x. To solve this limit, substitute pi minus x equal to y. Therefore, as x tends to pi, y tends to, if you substitute x tends to pi, y tends to pi minus pi is 0. Therefore, the problem becomes limit x tends to pi can be replaced by y tends to 0. Sin pi minus x is y. Sin y by pi into pi minus x is y. You take this 1 by pi out of the limit. It's a constant, therefore limit y tends to 0, sin y by y, this is 1 you know, so answer is 1 by pi into 1, therefore the answer is 1 by pi. That is problem number 15. Next one, very simple problem 16 also. Next problem 16. The observed examples in the book you should try to solve by yourself, please. I have solved exercise sums and I ask you to solve the examples by yourself because the examples are solved in your book. You try to solve the examples as your practice. Next, problem 16. Limit x tends to 0, cos x by pi minus x. You apply the limit immediately. You can apply the limit. Cos x is cos 0 by pi minus 0. Cos 0 is 1 by pi. Pi minus 0 is pi. 1 by pi is answer. That's all about problem 16. And now the 17th problem is somewhat some bigger problem. Next I am going to solve the problem number 17. Limit x tends to 0, cos 2x minus 1 by cos x minus 1. Cos 2x minus 1 by cos x minus 1. That is the problem 17. So this is expressed as limit x tends to 0. Cos 2x formula is 2 cos square x minus 1. For cos 2x, you know the trigonometric result, cos 2x is 2 cos square x minus 1. Already minus 1 is in the numerator. Similarly, cos x, 2 cos square x by 2, half angle formula, you apply cos x for cos x is 2 cos square x by 2 minus 1. Cos 2x is 2 cos square x minus 1. Cos x means 2x by x, 2x by 2. 2x divided by 2 is x. So answer x divided by 2 is x by 2. That is called, you apply half angle formula for cos x2, cos square x by 2 minus 1, already minus 1, like that. That is equal to limit x tends to 0, 2 cos square x minus 2 by 2 cos square x by 2 minus 2. So both the numerator and denominator, you can take the term, common term 2 outside, that is 2 into cos square x minus 1 by 2, if you take common, this is cos square x by 2 minus 1. Cancelling 2, numerator and denominator. And also, you know the result, sin square x plus cos square x equal to 1. You know sin square x plus cos square x equal to 1. So you bring this 1 to this side, that is cos square x minus 1 equal to, you bring this sin x that side, that is minus sin square x. So instead of cos square x minus 1, I can write sin square x in the problem. So this is equal to limit x tends to 0, cos square x minus 1 is minus sin square x. Similarly, denominator sin cos square x by 2 minus 1 is minus sin square x by 2. Cos square x by 2 minus 1 is minus sin square x by 2. Use these two results here. Minus into minus from numerator and denominator cancel. You will get the limit x tends to 0, sin square x by sin square x by 2. For that, I am going to write this as limit x tends to 0, sin x by x whole square. I can introduce sin square x by sin x whole square. I introduce x in the denominator also. So I am including x square in the denominator. Compensate it, I multiply by x square in the numerator. Similarly, the denominator is sin x by 2 by x by 2 whole square. Sin square x by 2 is sin x by 2 whole square. I introduce the denominator to the denominator is x by 2 whole square. To compensate it, I am multiplying by x by 2 whole square. So, applying the limit, this is limit x tends to 0, sin x by x. You can apply the limit as it is. Limit x tends to 0, sin x by x is 1 square into x square by. Limit x tends to 0, sin x by 2 by x by 2 whole square is 1 square. Sin x by 2 by x by 2. Sin x tends to 0 implies x by 2 tends to 0 also. Therefore, the denominator, limit x by 2 tends to 0, sin x by 2 by x by 2 the whole square is equal to 1 square. Use this result in the denominator. Limit x tends to 0, sin x by 2 by x by 2 whole square is 1 square into x square by 4. X by 2 whole square is x square by 2 square. That is x square. This is 4 by x square. X square by 4 reversely. Denominator to denominator become 4 by x square. This is, you get cancelled both. Your answer is 4. The problem 17 is 4. Answer 4. So like that, you have to solve the sums in the exercise and you try to continue the remaining problems by yourself, and I will solve the remaining problems in the next video. Thank you.